Hi, I'm John Casedu. Let's do some math. In this video, we're going to do some problems that include the power of a quotient rule. In this first one, we have 6u to the fifth quantity squared divided by 2v to the fourth quantity cubed. Now, according to the order of operations, we should do the numerator and denominator separately. And we're going to do exponents first. So we're going to apply the power of a product rule and simplify the numerator and get 6 squared times u to the 5 times 2 in the numerator. And then in the denominator, we have 2 cubed times v to the 4 times 3, which simplifies to 6 squared times u, 5 times 2 is 10, over 2 cubed times v to the 4 times 3, v to the 12. Now, we can simplify the numerical parts of this by rewriting 6 squared as 2 times 3 squared, which I think we did this yesterday, but using the power of a product rule, this is 2 squared times 3 squared. And so we have 2 squared times 3 squared u to the 10th over 2 cubed v to the 12th. Now, this 2 cubed can be rewritten as 2 squared times 2. So let's do that. We have 2 squared times 2, v to the 12th, 2 squared times 3 squared, u to the 10th. Now, 2 squared and 2 squared can be canceled. And what's left? 3 squared u to the 10th over 2v to the 12th. Next, we have negative 3p to the 4th quantity cubed over 6 cubed quantity squared. Now, I'm using much more unknowns in these problems because these are general expressions. I can substitute just about any number in here. If it's a denominator, I can substitute any number except a 0. But by using letters instead of numbers, I'm doing many more actual problems than if it was just numbers. So again, let's do the numerator and denominator separately. Using the power of a product rule, for the numerator we have negative 3 quantity cubed p to the 4 times 3 over 6 squared times q squared. Now, let's simplify that negative 3 squared. Negative 3 cubed. Negative 3 cubed can be rewritten as negative 1 times 3 quantity cubed. Again, using the power of product rule, this is negative 1 cubed times 3 cubed. And we know that negative 1 raised to an odd power is negative 1. So this is negative 1 times 3 cubed, or just negative 3 cubed. So we have here negative 3 cubed p to the 4 times 3, 12, over 6 squared times q squared. Now, we can simplify here because 6 is equal to 2 times 3. So 6 squared is equal to 2 squared times 3 squared. So let's rewrite that as negative 3, well, and we can go 3 cubed is equal to 3 squared times 3. So let's rewrite that as negative 3 squared times 3p to the 12 over 2 squared times 3 squared q squared. All right, now these 3 squares can cancel, and what's left? We have negative 3p squared in the numerator, and in the denominator 2 squared q squared. 2 squared q squared. Next we have negative 3u to the 4th v to the 9th over 2w to the 7th, all raised to the 4th. Now, there's a lot going on here. Let's see if we can simplify what's inside first. Let's rewrite this as negative 1 times 3u to the 4th, v to the 9th, over 2w to the 7th, all to the 4th. And then again, this is a power of a product rule problem. We have negative 1 to the 4th times all of that, again, 3u to the 4th, v to the 9th, over 2w to the 7th, all of that to the 4th. Now, there are no common factors in the numerator and denominator, so nothing's going to cancel there. Let's simplify this first. Negative 1 to an even power, that's a positive 1. And then let's use the power of a quotient rule and rewrite this as 3 to the 4th times u to the 4th to the 4th times v to the 9th to the 4th over 2 to the 4th, w7 to the 4th. Now, how did I do that? The power of a quotient rule says that if I have a fraction and I'm raising it to a power, let's call the power n for some natural number, it's the same as the numerator raised to that power divided by the denominator raised to that power. So this is just a little bit more complicated. I have combined the power of a product rule and power of a quotient rule here in that step. So using the power rule here, we have 1. Well, you know what? Let's not even bother writing that. 3 to the 4th times u to the 4 times 4, v to the 9 times 4, over 2 to the 4, w to the 7 times 4. And that's 3 to the 4 times u to the 16th, v to the 36, 2 to the 4th times w to the 28th. Now there is nothing to do to simplify that. That's the end of it. Okay, next we have negative of x squared to the 6th, x squared over x to the 7th squared, and all of that is squared. Let's simplify what's inside first. We can rewrite this as negative 1 times that fraction, x squared to the 6th, x squared, we don't need the parentheses, x to the 7th squared, all of that squared. Now, let's use the power of a product rule here. We have negative 1 squared, and then everything else is still there, x squared to the 6th, x squared over x to the 7th squared. Now, a negative number to an even power, let's posit 1. And then the power rule here, we have x to the 2 times 6 times x squared over x to the 7 times 2, and that's still squared. Let's work on the inside first. That's equal to x to the 2 times 6 is 12 times x squared over x to the 7 times 2, which is 14. And that's still squared. Now, we have here a product rule situation in the numerator, and that's x to the 12 plus 2 over x to the 14, still squared. In the numerator we have x to the 12 plus 2 is x to the 14 over x to the 14, all of it. That is squared. But x to the 14 divided by x to the 14 is 1 squared, or just 1. Now all of this works provided that x is not equal to 0, because then even from the beginning this problem wouldn't make any sense. But we're assuming that x is not equal to 0. The last problem we have here is negative 2a squared b c to the 4th 6 b c all cubed. Now, by the order of operations, let's simplify what's inside first. Let's rewrite that as negative 1 multiplying 2a squared bc to the 4th over 6bc all cubed. 2, we can divide here by 2 and there by 2. So we're canceling and dividing here by 2. Divide here by 2. We get a 3 down here. And we can cancel a b. B divided by b is 1. And b divided by b is 1. C, we can cancel here by dividing by c and there by c. So let's do that. C to the 4th over c is equal to c times c times c times c over c. Cancel one c. What's left is c cubed. But within the problem, we could have used the power of a quotient rule there. So this is equal to c to the 4 minus 1, which is c to the 3rd. So what's left in here is negative 1. In the numerator we have a squared c cubed. In the denominator we have 3, and c, all of that is still cubed. Now, let's use the power of a product rule, and this will be negative 1 cubed, and everything else is still there. A squared c cubed over, this c is already gone. So what's left in the denominator is just 3. Okay? So, a negative 1 raised to an odd power, that's negative 1. Negative 1. And then, let's use the power of a quotient rule, and we get a squared cubed c cubed over 3 cubed. And that's negative a to the 2 times 3 times c to the 3 times 3 over 3 cubed. And that's negative of a to the 6th, c to the 9th over 3 cubed. And that's it. Okay. All of this and much more is covered in the Pre-Algebra workbook series that's linked to in the description. Thank you for watching.